These notes are going to cover section 3.3, the properties of logarithms. So hopefully you've already watched the videos on how to derive these properties. And these three properties are definitely properties that you want to memorize. Okay, I'm not going to walk through them again. They're in your textbook. They were in the other videos. They're at the top of your note sheet. Okay, but it's very important that you memorize these three properties of logarithms. The next formula that is going to be important is to use, it's called the change of base formula. And so if you have something log base b of the argument m, you're going to find that you can do the log base m divided by the log base b. This is important because you only have log base 10 on your calculator unless you have one of the new fancier Inspiron or something like that. But for your general scientific calculator or a lot of the TI calculators, you only have base 10. So this change of base will allow you to find the logarithms of any bases. Similarly, you can, if you have, you can also change and just take the natural log of m over the natural log of b. So we'll go through some examples towards the end of our notes, but you do want to memorize all of these formulas. So our first type of problem is going to be to expand a logarithmic expression. So you need to remember, expand means to make bigger. Okay, so we have a single logarithmic expression and we want to expand it to smaller parts that we would be able to evaluate better. So the first thing that I always do is I always try to look for a pattern, okay? And I check my argument and see what I have going on there. So in my argument, I have a base raised to an exponent. I also have a base and it's taken the square root. And I remember that a square root is the same as an exponent to the 1/2. Okay, and I also notice that these two things are multiplied together, so I have a product. Okay, so the first thing that I'm going to do is I am going to rewrite this using the product rule. So I am going to rewrite this. I am going to keep the base the same for both of my expressions. And I want to take the first part of my product, the first factor, and I want to take the second factor. And just to make my life a little easier, when I rewrite this, instead of writing it as the square root of y, I'm going to rewrite it as y to the 1/2 because those are equivalent. So I have now expanded this. Instead of having one expression, I now have a sum of two expressions. To see if you're done, you want to see if you have any other products or quotients in your arguments. And then you want to see if you have any exponents in your arguments. Since I do have exponents in both cases, now I'm going to use the power rule. Okay, and I'm going to simplify these. The power rule tells me I just bring the exponent in front of my log expression and I keep that base. Similarly, I'm going to bring down the 1/2 in front, keep the log expression, and keep the y. So this is fully expanded because I have each of my arguments doesn't have a product or a quotient, and it doesn't have an expression raised to a power. So this is how I know I'm completely done. For our next one, again, I'm looking at my argument and I see that I have a quotient. So I'm going to use the quotient rule, okay, which tells me I take the log with the same base of the numerator and I subtract the log with the same base of the denominator. So this becomes log base 6 of the numerator. I am going to rewrite the cube root of x as x to the 1/3. And I'm going to subtract the log of the denominator, which is 36y to the 4th. Excuse me. I use parentheses more often than not to show that what really delineate what my argument is. Okay, I think that can make it important as you go along. So now I look at my first log expression and I see that I have a number raised to a power. So I'm going to use the power rule, and this becomes 1/3 log base 6 of x. Whenever you are expanding something after a negative sign, it's really important that you put the whole thing in parentheses, okay? Because you're going to need to distribute this negative to anything inside of the parentheses. So I am now going to rewrite this product as log base 6 of 36 plus log base 6 of y to the 4th. I can still simplify. My 1/3 log base 6 of x is not changing. My minus sign is not changing. Log base 6 of 36 is 2 because 6 squared is equal to 36. And I can rewrite log base 6 of y to the 4th as 4 log base 6 of y. Again, I'm using the power rule because I had an exponent on my argument. So now I'm going to get rid of my parentheses. 1/3 log base 6 of x minus 2 minus 4 log base 6 of y. Okay, I know that I am done here because in each of my arguments, I have a single value. Okay, I don't have any exponents in my arguments. I don't have any products. I don't have any quotients. So that's some examples on expanding logarithmic expressions. Our next examples are going to be to condense logarithmic expressions. So remember, condense means to make smaller. Okay, so instead of having an expression that has 2 terms, we want to rewrite this when we condense so that we only have 1 term. So I am going to use all of my properties backwards. So in my first expression, if I have a quotient in front of my log expression, I know that I can rewrite that as my argument to that coefficient as an exponent. And similarly, I have a coefficient, so I'm going to rewrite that as the logarithm to the argument, even if it has more than 1 term, raised to that exponent. Okay, notice the bases stayed the same. Okay, I'm using the power rule backwards. I'm taking the coefficient and putting it as the exponent. So next, I am going to rewrite this. I notice that I have a sum of 2 logarithms to the same base. So I'm going to use the product property backwards. I'm going to keep the same base of the log, and I am going to multiply my 2 arguments. Okay, I use brackets, okay, to help to show exactly what my argument is. And I honestly would probably rewrite this as log of the square root of x instead of using a rational exponent, x minus 1 to the 4th. Okay, oh, I'm sorry, you can't see that little part. But both of these are equivalent, both would be correct, marked as correct. Okay, and now it's fully condensed because I have 1 logarithmic expression with 1 argument. For my next one, if I look at my first expression, I'm going to use the power rule in reverse. I'm going to rewrite this as the natural log of x plus 7 to the third minus the natural log of x. Now I notice I have two logarithm expressions, so two natural log expressions. They're subtracted, so I use the quotient rule backwards, which tells me I keep the base, and when I have these two things subtracted, I take their quotient. So I have x plus 7 to the third over x. Our last one is a little more complicated. Honestly, as a trick, as something that gets faster or makes this faster for you, I am going to rewrite our first expression as log base b of x to the fourth. I used the power rule backwards. I brought the coefficient up as the exponent of the argument. My trick here, I am going to subtract. I'm going to pull out the negative. So I'm going to change this to log base b. I'm moving that 2 onto the 6. And this minus is now changing to a positive because I factored a negative out front. And this is going to be log base b. It would be y to the 1/2. I'm recognizing that y to the 1/2 is the square root of y. Okay, so I did this in a couple of steps. The first one I think is pretty easy to see, log base b x to the fourth. I'm factoring out a negative. So this negative means this coefficient needs to be positive. Since the negative 1/2 was negative, this coefficient needs to be positive so that when I distribute that negative, those would both be negatives over there. Okay, so now my first expression is not changing at all. My negative is not changing at all. Now I'm noticing that I have log base b 6 squared. I'm going to rewrite that as 36. Okay, and so now I have the sum of two logarithms with the same base. So I'm going to use the product property backwards, and I get log base b. I'm going to find the product of those two arguments, 36 square root of y. So now I notice I have the logarithm to the same base, and I'm subtracting them, which means I can use the quotient property backwards. So I get log base b of x to the fourth over 36 square root of y. Okay, again, I know that I'm done because I have one logarithm expression. Okay, and if I think about this, if I did this backwards, I would have log base b of x to the fourth minus log base b of 36 square root of y. If I broke that out, I would have here. Okay, and then that would go to here. So you can check your work backwards. A lot of times, students will forget to factor out the negative. So let's see what happens if you do that. If you just start putting in all the exponents, you will have log base b of x to the fourth minus log base b of 6 squared. So I'm going to rewrite that as 36 minus log base b of the square root of y. Okay, again, I'm putting the exponent of 1/2 on the y. That changes to square root y. So now let's condense the first two log expressions using the quotient rule. quotient property. So we're going to get